more complex. So I have prepared like a little table of precedence here. We're going to get to that later. And the second example, we're going to do the little t graph here again. We're going to write stack and output. So we're going to start this way again. So we put A in the output, the operand, and then we got the plus as an operator. We got the parenthesis, and then B. We got multiplication, we're going to put it here, and then we got C, and then we have the division. But you see, the division should go here, but the precedence of multiplication and division are the same, and that can't happen when you do stacking. So when the inserted operator has higher priority than the remaining operator, then there's no need to pop. But since they have the same priority, we're gonna pop this one, the remaining one, and put it here, and then we will have this left in the stack. And then we go on to the next one, which is D. We put it here. Next would be minus. But you see, minus is precedence is lower than division. So if minus goes here, you actually need to pop this one out and leave the minus here. So whenever a higher operator comes into the stack, you don't need to pop. But if the remaining operator has higher precedence, you have to pop it out. So we would have this in the remaining stack, and we would pop this division here, and we would have this as the output. And then next we go on to E. We put it here, of course, and this is not the power of. This is XOR, bitwise XOR, and its precedence, you can check it in this table. So it's here, and it's lower than additive, multiplicative, anything. So you can just say that this has like a lower priority of like the operators that are written above. So what we're going to do is, since it has lower priority, what are we going to do if we meet the minus? We're going to pop the minus, because this has higher priority than this one, right? Alright. So we're going to have plus XOR, and we're going to pop this minus here, right? So in our output, we would have this, and in our stack, we would have this. The next one will be F. I'm going to write it here because I'm running out of space over there. So we have this, but next would be F, right? So F would go here, and then XOR again. When they meet, like since they have the same priority, it should go here. Since they have the same priority, we're going to pop one out and then leave this one in again. So like this, we're going to pop one out here. This would go here. And then next would be I. And then we have plus. Now plus goes here. So we have to check the priority between these two. But since we know that plus, the additive has higher precedence then this bitwise XOR, we can leave it there. Okay, so next would be G, right? Okay, next would be G, so G goes here. So if I write down the output one more time, we have this, and then we have another parenthesis. We're gonna close it. Now when we have a closed parenthesis, we're gonna pop these out first before we go on to the next step. So we are going to have a plus here, A, B, C, D, E, F, I, G, and then when you pop out stuff in parenthesis in the stack, you pop it out this way. So we're gonna put plus first, and then the bitwise XOR. So we have this as the output, and then we have a plus in the stack, and then we still have two more steps to do. So the division comes here. Yes, the division comes here, and then we put H here. Now we have this as our final level in the stack and output, so we have to pop these out, right? So our final answer of the postfix expression would be A, B, C, D, E, F, I, G, plus H, and then this first, and then this. So this would be our final answer for this infix form to a postfix expression.